Hi, hello, everyone. My name is Xiaoning. I work at NUFAB, mostly in charge of the thin film deposition tools and the etching tools, including the wet dry etching and wet and dry etching tools. Today, I'm just going to introduce you to new equipment in our lab, plasma assisted deposition and etching tools. As some of you may have noticed in our lab, we recently have two huge equipment. They're made by Samco. One is the PECVD plasma enhanced chemical vapor deposition tool, and the other is the deep RIE, deep reactive ion etching machine. They are so easily to be spotted in the lab, and some of you may already have started using, and some of you may be wondering what they're for and how it can help your research. So this is the general review of these two tools and a little bit touch and compare with our existing tools in the lab, because we have another two similar tools which have the similar functions, and I will just go a little bit comparison which one to choose today. In the future, we may have some more talk about what thin film tools, deposition tools you're gonna choose in the lab, and which etching tools is best for your research. Okay, so as I just go over quickly, for the deposition tools in our lab, thin film deposition, we have PECVD, plasma enhanced chemical vapor deposition, and then we also have several other physical vapor deposition tools like sputter, e-beam evaporator, and the thermal evaporator. Among all of these tools, Samco PECVD, which is made by the company called Samco, and STS PECVD, they are used for dielectric thin film, silicon oxide, and silicon nitride deposition. The STS PECVD is the existing tool. Many of you may already have experience with it, and this is the new one I'm going to show in the next page. Samco is the new one. So the other tool is dry etching, deep reactive ion etching tool. Um, and we also have conventional RIE, regular reactive ion etching tool in the lab. So today we're mostly focused on this new Samco deep RIE. The counterpart, the older existing tool is made by STS. They are both for deep silicon structure etching. Deep means more than a couple micrometer thick. So the working range for deposition, thin film deposition, is usually less than 1 micron. And for deep etching today, we're talking about usually a few tens micrometer range. Deep RE is a special etching tool. It's ICP, inductive coupled plasma etching tool, with a Bosch license. I will give you a little bit detail of this process in the next few pages, and it uses really high RF powered cells. It's in the kilowatt range, really strong. So the etching rate will be very much different from what you have experienced with the RIE. So this tool is mostly designed for very high aspect ratio. Straight wall means 90-degree vertical wall, side wall of the etching pattern. It is not intended for wafer thinning and film coating. So if you have the need for wafer thinning and film coating, so you may come to us. We have much easier alternative ways for you. Okay, let's go into a little bit. Hold on, please. Okay, back a little bit about plasma technology. So what you see on this screen are two kind of plasma generating technology, which are mostly commonly used in the lab or in the industry. So the left side is a coupled capacitive plasma generator. It is sometimes people call it a parallel plate plasma. And the other side is inductive coupled plasma. So the electrode to use to generate the plasma is wrapped around the chamber, is a coil wrapped around the chamber. So basically both of these technologies, they will have very strong electrical field, which is powering the electrons and the gases in the chamber to form the plasma, including the ions, electrons, and the radicals, the gases, which is the gas phase. Either you can have the chemical reaction generate material, some film, which is called the deposition, which is the PECVD, or you can causing some etching reaction, which is the removing of some material, which is etching process. Both of these configuration can be used either for deposition or for etching, depends on what chemical or gases you introduce into the chamber. So the left one is what we have for our sample PECVD. We use the saline gas, ammonia, and the nitric gases as a reaction gases. In the plasma state, we either generate silicon oxide film or the silicon nitride film. And on the right-hand side, we use the SF6 and oxygen gases mostly to generating etching plasma to remove the silicon. Okay, this is the very simplified concept. So next page, let's take a look of this one. So right here, what you see is the sample PECVD. It has a load lock here. We use the load lock and etching chamber. So separate into two small chambers, which can provide you faster loading and unloading process. Operation is through the touch screen here. We have the convention of what you have been used in the lab is the silane-based silicon oxide and the silicon nitride. In this new system, we have a new silicon oxide procedure. Actually, we use a different chemical. It's called TIOS. So this is a complete new. TIOS-based silicon oxide is widely used in industry. It is a lower temperature process than our current silicon oxide process. Why we introduce this one? Because it has some advantage like it can provide lower deposition temperature. Current temperature, we're working with existing tool and silane-based. This one silane-based process is around 300 to 350 degrees C. TIOS-based process is 250 C. And also it provides a little bit smoother surface and is a little bit more conformal. That means it has better coverage, step coverage if you have some etching structures on your wafer or some deep trenches. This one will give you a better sidewall or corner coverage. Deposition condition, which is the same, we have low frequency power supply, which is around 400K, high frequency, which is RF radio signal, around 13.6 megahertz, and MF means we can mix these two signal for your process. What this new equipment handles is, it handles 4-inch till 8-inch. What you see on this right side, this is the picture inside the load lock. We have a sample tree, which is a silicon carbide sample tree. You can load either this big one, 8-inch wafer, or you can load a 4-inch wafer. So the big one, what you see is we made a retainer to hold the 4-inch wafer in the center. So basically, if your sample is actually between 4" to 8", no problem. You can even do smaller sample like 3" wafer, or even sample chips, the wafer chips. But for that one, we need a little bit smaller carrier wafer. We will have the instruction for you how to make a carrier wafer. This one, the way you load your sample is very much friendly for double-side polished wafer. With this retainer here, this ring, this purple color retainer, if you have a double-side polished wafer, it won't slide off the sample holder, and it will be centered all the time to help you increase the uniformity of across your sample. We have 3 standard recipe to choose from: standard silicon oxide, nitride, and standard TiO oxide. If you want to create a really special recipe, very much different from our standard, you can come to us. We'll discuss the feasibility of your process, help you going through it. Okay, next page. So among you, you may notice on our equipment list, we have another PCVD, which is called STS PCVD, or sometimes we call it SPTS, which is the company's name. When it comes to your project, which tool to choose, we have some comparison data here. Basic answer is, for standard silicon wafer, if your sample is standard silicon wafer or silicon oxide surface, it doesn't matter which tool you can choose. You can choose either one upon your flexibility about the plating temperature. Plating temperature is the surface your wafer will be sitting on inside the chamber. New SAMCO slightly higher, around 350 degrees C. And the STS is 300 C, but the temperature flexibility in STS is, the room is bigger for now. We have tried many other temperature which still runs well. So you can come to me if you want to run a lower temperature or a slightly higher temperature on STS, which is fine. For SAMCO, the temperature is pretty much fixed for each process. Silane-based oxide and nitride, they all run on 350. TL space run on 250 C. Deposition rate. Some of you may like faster because you probably will need much thicker film, thicker in the thin film area. Society means over 500 nanometer till 1 micron. That considered thick film. But if you really want to go higher and you want faster process, SAMCO is faster. You can see the number here. 75 is the TL's deposition rate. 117 is the silane-based oxide rate. But some of you may need to go really thin, down to 10, 20 nanometer range, which I would suggest existing STS nitride, which is easier to tune the time. Because of the high rate of the SAMCO, it is not suggested to go down really thin, because your process control window will be very narrow. Other different material restriction compare between these two. SAMCO is more strict. STS, we have some specially approved material, but both will not allow metals. For polymer, no any polymer for SAMCO, and no photoresist for STS, but we do have some special polymer pre-approved for some of the research groups. If you have one, you can come to us and we'll help you evaluate how to make sure your polymer is okay to survive the high temperature plasma process. And we also not allow any high vapor pressure materials. Both of the equipment will not allow any of these, like sodium, zinc, magnesium, lithium, sulfur. They are very contaminating. For power type, both machine can provide low frequency, high frequency, or mixed frequency signal. If you have special need to tune the film stretch, you can come to us. Usually, high frequency signal will provide a tensile stressed film. Low frequency is more compressive stressed film. Mixed frequency will give you the best balanced film stress, but it's still a little bit tense to tensile, but it's not absolutely neutral. Okay, so this is a summary to review what I have just mentioned. If you have non-standard material, you want to coat silicon oxide or nitride, you may need to consider STS machine and double check with me what is the best condition for it. If you want a little bit lower deposition temperature, both machine are fine. You can either choose TLs at 250, or you can ask me among these two machines what a specific temperature. If you want a specific temperature, which one is best for you? Stress balance film, both can do that. Faster speed, Samco. Some films, which is now standard process in our machine, such as oxynitride film and amorphous silicon. You may explore with XTS PCVD, but you please check with me what is the recipe and the condition to run. If you have double-side polished wafers or double-side polished small sample chips, Samco is a better choice. It holds a small sample much better, and it will release you from a lot of work, sample preparation work. Okay, so this is basically about the Samco PCVD. Next, we move quickly to the Samco DPRE. What you see here to the right, this is the new machine. The same, all the operation is through this touch screen, and the loading unloading through the load lock. Process chamber is in the back sealed. You won't be able to see anything which is separated from this load lock. Okay, load lock is a faster way for loading and unloading, because each time you only need to vent and pump this smaller chamber. You don't have to wait the big chamber to get to the required vacuum. So the Samco DPRE, it provides a really high rate anisotropic etching. From this animation, you will be able to see what is an anisotropic etching. Basically, we sometimes call it high aspect ratio. It means you're gonna have a big ratio per X lateral size and the Z dimension. And also anisotropic is going straight down, is only going down in one particular question, not to the a particular direction, not to the other direction. Counterpart isotropic means the edge will go to all the direction at the same rate, but for anisotropic, it only has a rate in one direction. So basically, this is an alternating of etching and the passivation process. The etching process is using SF6 gas plasma and etches a little bit through your silicon, and it will quickly go to the deposition process, coating a passivation layer using the C4F8 gas in the plasma environment. It will coat a thin layer, very, very thin layer of protection over all the surface, flat, vertical, and the bottom of the trench. Then the process quickly switches to the etching again with SF6 and the bias signal. So it will first remove the polymer on the flat surface, including the bottom of the trench. And also once the thin polymer on the flat surface is first removed, it will go on to the edge of the silicon. So the side will coat it with the polymer. It will remove a little bit, but not all, because the ion direction is mostly in parallel with it. So this process is a licensed process called batch process, which is a particular name for this kind of vertical etching. So to this particular etching process, which has a backside helium coolant, which is applied to your wafer to help you maintain the wafer temperature. Also, another feature we have is electrostatic wafer clamping. It doesn't use any mechanical clamping. These two, the reason I list them here is we request the wafer to be prepared in a particular way, and the etching, you won't be able to etch a wafer straight through. We have to ask you to prepare the wafer in a special way. So these are the examples of what we can etch in this machine. You can see this is a white silicon trench etch. The width of this trench is 300 micrometers, and the depth is over 300, actually nearly 400. And this is a smaller trench. Is about 5 micrometer wide, 10 micrometer deep. New feature in this one, we can etch silicon oxide. It is also anisotropic. Even not as nice as the silicon anisotropic, but it's much better in silicon oxide etching society. If you want to etch silicon oxide to this kind of shape, nearly 90-degree side wall, you can come to us and check with us. So here is a little bit comparison between our existing STS DPRIE plating temperature. Okay, sorry. It is the temperature your wafer will be sitting on. For the new SAMCO is 20 degrees C. STS is 15 degrees C. You can change this a little bit higher to match it. Basically, the temperature, the purpose to put the temperature 15 to 20 is to help you have a better, etching mask life for the users using photoresist as a etching mask. By the way, to etch deep feature in these two machines, we only have two choices of etching mask, which is silicon oxide and photoresist. Okay, chamber temperature. Surrounding temperature in the chamber, they are all high to prevent deposition. On the side will also provide some energy to the ions. Etching performance. So for silicon fine pattern talking about if you want to etch a trench, a hole, whatever the pattern, opening size is less than 10 micrometers. We have a standard recipe called fine pattern in new SAMCO, and another standard called Spec A in the existing STS. They're equivalent. They both etch about this range. 2 to 5 micron per meter or even smaller. In the next page, I'm going to explain why the etching rate is always a range. For the wide trench, means if you have a big opening, a big chunk of silicon opening to remove, usually more than 50 micrometer wide. You can choose the wide trench recipe in the sample, or spec B and the spec C in existing STS. So the etching rate is also comparable. Also, it is a range, could be really fast or could be really slower. So this all depends on how you design your etching pattern. We'll see from the next page. So for the silicon oxide etch, currently this is the only two sample you can do that. Etching rate is around 100 to 500 nanometer per minute. Also depends on how you arrange your pattern design. So some common point between these two. They all handle 4-inch wafer only. This is not like the PECVD, we can handle up to 8-inch or smaller samples so easily. For these two machines, both of them standard sample size 4-inch, but you can handle smaller samples, like cut silicon chips or smaller cut glass slide, no problem. We have special ways to handle that. We can give you the instruction when you ready to start. Also, both equipment only handle single side polished wafer. No metal allowed. No polymer etching. The only polymer we allow into the chamber is the photoresist, which is working as an etching mask. Both of the equipment use the radio frequency signal and the low frequency signal as a power source. If you have special sample, you can come to us. We'll give you same instruction on how to prepare it. Okay, this one gives a little bit insight into the etching rate and how to choose the equipment. Basic etching principle is the same. Silicon oxide etch using SAMCO. This one is actually an SAP etch. It doesn't use the batch process. As discussed previously, for silicon etch is a etching deposition alternation cycling process, which is called batch, but it's also based on SAP power. For silicon oxide etch, we don't do the alternation. It's just SAP keep etching and etching, no deposition process. If you want to etch deep trench, you can choose both. So here for deep trench etching, a little bit, background. So we have terminology called loading effect. Generally, is talking about, say, if you have an area on your wafer, on your sample, you put a lot of openings, a lot of features together, but in other part of the wafer, you only have one opening. So that means somewhere you have more pattern density, somewhere you have low pattern density. So the etching result will be lower pattern density will give you a higher etching rate. So that's why we always have a range of the etching rate. Also, if you put two different opening size in your mask design, so you have, for example, this is 5 micron only. This is nearly 200 micrometer. You put the design on the same piece of wafer, you're going to get much slower etching in the smaller opening. So what I suggest is you even out, like pattern density even out. Try to make the feature size closer as much as you could. And if you couldn't, try to put some dummy patterns nearby to even out the etching rate. Also, this also requires you calibrate your pattern etching rate. Say if you have one pattern design today and tomorrow you're gonna have a totally new design, you have to calibrate etching rate per design. They will give you different etching rate. Okay, so For wafer thinning, as you have seen, this process really technique-based design require intensive. If you want to thin a wafer, simply you have no patterns, you just want to make the wafer thinning. We have some other easier ways to make you stay away this complicated process, operation and the design phase. You can come to us, we'll give you, some suggestion based on your need. Some users also ask me to use the DPRE as a non-stick coating process, which is not this machine. We have other equipment which is called paralleling coater, which can give you better solution. Why? Like you see this illustration, the batch process will generate scallops on the sidewall. No matter how you tune the process, it will always have. So this is create a bigger roughness here. If you use the paralleling coating, so it will give you some thickness, much thicker coating than the DPRE to smooth the sidewall. Okay, sorry for this. To cover the range, the dimension of this scallop feature is around 50 to 90 nanometers, which cannot be done by the DPRE. Most of you to make such deep features is for making a PDMS peeling mask, the mask. So you're gonna input some polymer, let it cure and peel it off. So if you have so much roughness on the sidewall, it's going to be really difficult. The paralleling coater can help you to cover all these scallop, make it smoother and easier to peel out. If you have special need or questions, you can come to me after this. So basically, this is a summary of what we go through. We have started, engaged the new equipment, PECVD and DPRE with comparable performance to our existing counterpart, STS counterpart. Users can choose between either one. If you have questions, you can come to us. We can give you some suggestions. We have some new features. From the new Samco PECVD, you can do TILS oxide, which can give you better step coverage or corner coverage and a smoother surface. For DPRE, we can add silicon oxide, anisotropic of silicon oxide to pretty much deeper depths on a few micrometer range or to tens micrometer range even. So there are some flexibilities in existing STS but the newer Samco has stricter requirement of your sample sample material type. If you want to know more of this, kind of like there are a lot of other technical background on choosing the equipment or having your process getting a better, criteria level. A lot of to talk actually, not one talk to cover. So I know usually user may have a difficult material to handle. We have some other, ways to go around between tools. Maybe we can have some other tools like sputter, evaporators to help you to seal your not so qualified samples first and then work with PECVD or DPRE. So come to us if today's talk is not enough, but we're gonna to have a more detailed technical based talk on each particular to PECVD and the DPRE in the future. So far, this is all I want to cover today. If you have questions to start a new project or to have some difficult situation in your current project, you can contact me or Nasser for both tools. These are our contact. Thank you for being here today.